Hi, your next programming challenge is entitled Hamming Distance. Hamming distance is the number of characters that differ between two strings. To illustrate, let string 1 be ABCBBA and string 2 is ABCBDA. The Hamming distance in this case is 1 because the B and the D in string 2 is the only difference. A is A, B is B, C, C, B equals B. Here's the one difference, then A is A. Since only one character is different between them, you would call the Hamming distance 1. And then they provide a couple other examples down here. Notice in this first example, it's the start of the alphabet, then it's starting the alphabet from the second character, so even though they have a lot of the same characters, they're technically all different when you line them up character for character when you align the arrays, the character arrays up. So you get all 5. The Hamming distance is 5. They're all mismatched. Example 2 is 0. These strings are identical. And your third example, the difference between strong and strong is the one letter, O and U, hence 1. We'll check their notes. Both strings will have the same length. That's easy enough to enforce. So we'll add that too. On to the coding. Please implement this yourself and then resume the video. So I will really quickly add that check. If string 1 length is not equal to string 2 length, let's just return -1 to stay simple. That would be an error. We're not allowing that. Once we get past that, we know the strings are the same length. Now, you could do the usual looping for this, right? You set up a loop that's goes from 0 to the length of either one of these strings since they're the same length. And then at each iteration of that loop, you're examining the character in question. So you take string 1 index 0, see if it equals string 2 index 0. If it doesn't, then you're going to increment some counter variable that you set up outside of the loop. And once you're through the loop, you have your count and you return your count. That's a fine way of doing it. Again, I'm going to try and use some built-in techniques, working with collections to introduce some new topics to you and try and stretch your brain that way. So, but you're fine if you did the loop method. Anyways, I'll get on with it. I'm going to use this zip method from enumerable. This is a good description here. Applies a specified function to the corresponding elements of two sequences, producing a sequence of results. So this is a very generalized way of talking about it because, you know, they're dealing with generics. It's purposely made that way so you can use it with about any collection you want. I'll start describing it in terms of what we're doing. Hopefully that will be less abstract and more clear. We're dealing with strings, which are character arrays, so you can think of our collections as arrays. So imagine when they're talking about two sequences, then we're talking about two arrays, and we're going to give it some function for handling the elements of two arrays. And again, like we talked about, this happens on a per element basis, so we're going to take element 0 from each, do something, apply some function. Then we're going to get element 1 from each collection, do something with that. Then element 2 with each collection, do something with that. And, you know, the way I like to think of it with a zip, if you imagine a zipper, right, on your jacket, you've got the teeth on both sides, and as you zip it up, they sort of merge together. It's a little bit different because the teeth are sort of staggered to form the closed zipper, but imagine that they sort of fall on top of each other, the teeth. And that's what you have here. You're going to get some output collection that's the same length with whatever different kind of results that you want to transform that into. And so we'll do that. So we're going to say, let's see if they might have an example here. Yeah, here you go. Look at this. So they got a numbers collection, a words collection. Notice they're different types. There's nothing requiring them to be the same types. This was implemented with generics. And so they want this number and words collection. They're going to take the numbers, they're going to zip it up with words, and they're taking first and they just called their parameters first and second. Remember, there's two of them. One is going to be drawn from this collection, one's going to be drawn from this collection. And then they chose to just take the first and put a space and then add the second, and then you can see what happens. Number one, space, and then one. Remember, one match one, first element, second element to second element, third element to third element. So, yeah, that's sort of how that works. We'll do something very similar to this. So let's take string 1, zip. It's going to be zipped with string 2. And now we're going to have two parameters, right? One's going to represent an item from string 1, one's going to represent an item from string 2. We know these are character arrays, so I typically like to call mine character 1 and character 2. And I believe I needed an include for this. Yep, so it's from the link. Let's add that too. Using system link. Good. And now, anyways, sorry for the interruption there. This is the first part of our Lambda statement, right? We had to give this thing a function that describes what to do with each of the elements. So we're going to give it two characters, one from each collection. And then what do we want to do with these? Well, for now, what I decided to do was just sort of package them up into an object and just pair them together. So I'm going to say new. So this is, let me show you, what we'll call an anonymous type. It's almost like a lambda is to a function, where what this is to objects. With the lambda, it's an anonymous function, right? It doesn't have a name, but we're still giving it the input parameters and what to do with those parameters, just like we would define a function. But it's a sort of one-off throwaway thing that we just make in place. We define it in place because we won't need it anywhere else. And it's a nice shorthand. And the same thing here. I could define a proper object with these fields, but if I'm not going to use them again, this is a nice way to just create it in place, throw it away. I don't have to define a full object, that sort of thing. It's kind of analogous to what, you know, if you compare a lambda to a function, this is sort of the same concept applied to an object. At least that's how I think about it. So, yeah, just think we're packaging up an object with some fields in it. And what I did was, I'm packaging this object up so it's going to have an entry for character 1, an entry for character 2. So you can imagine then as this zips up, we're going to have a third collection produced with the results, and each element of this third collection will contain this pair. It's going to contain two characters, one that came from string 1 and one that came from string 2. Hopefully that's clear. So if string 1 was A, B, C, D, E, and this one's B, C, D, E, F, like we saw in the examples, the first entry of this new collection would have a field storing A for character 1 and B for character 2, and then etc. for the subsequent indices. So at this point, okay, that's fine. We have a third collection now that results from this call, right? We zipped it up. We created a third array that has all these pairs in it, but that's clearly not the Hamming distance, right? So what I'm going to do next is take this third collection that's the same size, and I'm going to filter it. And I'm going to do that with this where statement, this where method, also from link. And it filters a sequence of values based on a predicate. So that's nice. It's a filter. We can throw out elements that we don't want. And I'm going to use that to remove the matching characters, because I only care about the ones that are different for this Hamming distance. And when I do that, I should be left with only the pairs whose characters are different. And then you'll see it'll be easy to get that Hamming distance from there. Let's see if they have a good example for you. Okay, so here's one, right? Fruits, they got this string array, and they're selecting fruit where their length is less than 6. So apple, sure, but definitely passion fruit contains more than 6 letters, so you notice that doesn't appear in the output. It's a nice way to filter your array and get things out. That's really powerful, right? You can imagine if you had a collection of things and you want to use one of these filters because you only want objects of a certain color, or whatever kind of object you're dealing with, integer, even values, anything like that. These are really nice for getting a collection, a sort of subset, if you will, of the superset that meets criteria that you want it to have. So cool, that will work well for us. And I want to say where, let's see, we're going to have to give it, we're going to use a lambda for where, so we got, each of our elements represents a pair. I'm just giving it a name, right? We named all of our variables. Since this holds 2 items, I'm just going to call it pair. Hopefully that's a good name for it. And I'm going to want to know where pair ch1 is not equal to pair ch2. Right? We care about the ones where the 2 values are different. If they're the same, we don't want to include them. We only want the ones where it's different. That's going to help us get our Hamming distance. So this will filter out all the matches and give us only, you can think of it as making another collection where it's going to filter out those matches. And then I'm going to simply count them. The count of differing characters is the Hamming distance, as they told it to us. So let me see if I can even try and get this all visible on the screen for you. Okay. Oh, here we go again. Looking for an integer. Gotta return something, right? Cool, yeah. So that's a little bit different than the looping way. It may, in the short term when you do this, it may seem harder than just writing out the loop yourself, but I would still encourage you to use these sort of techniques, these built-in methods, because as you move on to other more complicated problems, these will become more useful to you. It'll be more obvious why they're helpful than it is maybe in a simple case like this. But yeah, hopefully you followed along. Zip, we're going to zip string 1 up with string 2, do an element by element sort of joining, but we define how this merging sort of happens, and it results in a third array. We don't mess up the string 1 or string 2. We're going to produce another collection as a result of this zip, and we told it to take one element from each of these strings in turn, starting from index 0, from index 1, 2, 3, etc. And we're just saying, hey, for this third collection that we're making, we're going to throw a pair in for each entry, and it's simply going to hold character 1 and character 2. So that results in a collection of the same size. It's going to hold the matching ones, it's going to hold the ones that mismatch. So you're going to have this new collection of matches and mismatches. Then we throw this filter on top of that collection where we're going to discard all of the pairs. We're calling them pairs just because it had 2 entries. We're going to discard all of the pairs where the characters don't match, because that doesn't contribute to the Hamming distance. So then we get this other collection as a result of this filter where all of the pairs have a mismatch, and then we simply count them, and that's our Hamming distance. So hopefully that was clear. If not, hit me up with questions below, and thanks for watching.